Okay, so so we get into 12.2, and remember, we're going to start talking about things called chords and arcs. Okay, so again, you have to know what these pieces are. Okay, first, you have diameters and radiuses. Those are all diameters, right? Everyone should know what a radius is by now. And you know a diameter goes all the way through. Well, that diameter is a specific name of a chord. Hopefully you know it's the longest chord. Okay? So any line that touches the circle twice is a chord. Notice it's still in the circle. So that's a chord, that's a chord, that's a chord. Those are all chords. Okay? And understanding that the longest chord is a diameter. Okay, the longest chord is the diameter. But any line segment that stays in the circle and touches at two sides is also a chord. That means the endpoints of it are on the circle. Notice it doesn't continue out. That's got a different name. Okay, so understanding what a chord is. Okay, and then we talked about arcs. And we've actually already talked about arc. We talked about the length of the arc and the measure of the arc. This is an arc. It's a piece of a circle. Okay? And what do we know about the arc and the central angle? Their measurements are always congruent. So if this angle is 60 degrees, that means this arc is 60 degrees. What do I know about all the arcs in the circle? They will always add up to 360, correct, our magic number. Okay, so understanding the pieces of the whole, being able to find the pieces, their relationship between each other, understanding that arcs and angles are the same measurement. Okay, so that's just some basic anatomy type questions. All right, now we get to the rules. Okay, the rules are relatively basic. Okay. If your central angles are the same, then the chord is also the same. And if the chord is the same, then their central angles are the same. Okay? So in other words, if I draw it like this, and I do this, and then I draw this one, if I say this angle and this angle are the same, then if I were to draw the chords, those chords are the same. Okay? And it's very similar to what happens in an isosceles triangle. Even though these are two triangles, equal angles are across from equal sides. Okay? Equal chords. Okay? We're comparing the two, just like similar triangles. Everybody remember that? Right. Same concept. So if the center angle is the same, then the chords are the same. If the chords are the same, then the central angles are the same, forwards and backwards. It also goes to the chords then. Okay? So that means, or excuse me, the arcs, because we're talking about chords and arcs. So that means if the central angle is the same, or the chords are the same, then the arcs are the same. If the arcs are the same, then the chords are the same. If the chords are the same, then the central angle is the same. All these things are congruent to each other if one pair is congruent to each other. So if the two chords are the same, then the arcs are the same and the central angles are the same. So it's being able to add the congruency marks to all the things that match. M-A-T-C-H. Okay? So that is the first rule of 12.2. Understanding that if the chords are the same, then the arcs are the same, then the central angles are the same. Okay? So finding those measurements. All right. First concept. Real easy, not too complex, but it's understanding that if you say one is the same, then the other is the same, and so on and so forth. Okay? That's the first rule. The second rule. The second rule deals with chords as well. But that rule states that if the chord is the same distance from the center, then the chords are the same length. And if the chords are the same length, then they're the same distance from the center. Notice we're talking about the distance from the center. And you can see that we're talking perpendicular distance, which allows you to make what lovely shape if you need to? Correct, a right triangle. And in this case, your right triangle, that hypotenuse will always be the radius, just like when we did regular figures. Okay, so the radius is always your hypotenuse. Right? So understanding those two big concepts. One, if your chord is the same distance from the center, then the chords are equal. And if the chords are equal, then they're the same distance from the center. Okay? And then you can put measurements on them. Hopefully you also know that there's going to be perpendicular bisecting. So all those segments would be the same measurement as well. And then if you need to find certain things, you would be able to use Pythagorean theorem to find certain measurements. Okay? All right, so what I want you to do is I want you to do the Got It problem on page 805, and then I will click, pause it, do the Got It problem on 805, and then we'll go over that answer, and we'll talk about, you'll start on the work for 8.2 section 1 tomorrow, and then 8.2 section 2 on Wednesday. All right. Thank you.